Okay, hello, this is Dr. Janes, and today we're going to talk about building a high-speed signal generator. Let's see if I can get this thing under control. Right here, using a potentiometer and a Teensyduino 4.0, which has got a screaming fast clock speed of 600 megahertz. And I'll talk about the hardware and the sketch to do this, and show how this thing works. And it looks like it works pretty good. Okay. Okay, hello, this is Dr. Janes, and today I'm going to talk about the Teensyduino 4.0. It's got a blazing clock speed of 600 megahertz, and I'm going to build a digital oscillator. I mean, this is one of the ones that's really got enough horsepower to produce a reasonable oscillator for maybe some Tesla coils or other things. Should be interesting, tunable oscillator. And what I'm going to do is I'm going to take let's see, maybe I got these potentiometers here. Let's take a look here. And the way you can generate a tunable source is you take a potentiometer and let's put these away, and then you hook some wires up to it. And I figured I bought this for another project. Bunch of wires. I'll cut a snippet off of this. Let's see, maybe I don't know, a few inches. Oh, it doesn't hurt. I won't be stingy. Let me just make it a little bit longer, because you never know where you might want to mount the project. Okay, and there's our spool of wire that I ordered for another project. And so let's take this Teensyduino, and I want to use 3 pins to make a voltage across one of the analog inputs. Now it's important to realize, I checked this, that the Teensyduino really doesn't want to see more than 3.3 volts. Some of the other Arduinos can handle higher voltages. So you're going to hook up to a ground, the 3.3 volts, and then the middle pin of this variable potentiometer will go to the, we'll probably put it to that pin since that's the closest, A9, pin number 23. Okay, so let's get started. Okay, so let's start with this. We have 4 wires here. I'm going to actually cut one of these wires off. Let's start with a razor blade. So I'll just have 3 wires, and maybe I should have done the red in the middle. Well, I guess it doesn't make a difference. Okay, and I think I'll just split these wires up with the razor blade and then strip them. Okay, let's do that. Okay, so I got them all separated, and you can use whatever method you want to strip the wires. Usually this works pretty good though. I'll just continue to strip these wires back and get them ready to solder into our Teensyduino circuit. Okay. Okay, so here is our Teensyduino circuit, and let's see, I believe that one is not labeled as ground. And then there's 3 volts, and then there's the pin 23 that we want to go into, which is also not labeled. And so I'm going to thread these wires into there. Oh, come on. I'm going out of focus here. Okay, so I'll thread those wires into those holes, and see if we can get this ready to get it soldered up. Okay, so it wasn't the easiest thing to do, but it wasn't the hardest thing either. So I got the wires through there, and I kind of bent them over on the backhand side, and we'll get our soldering iron out and see if we can solder this guy in place, these 3 wires. I don't know if you can see that. Okay. Okay, so got our board propped up with the wires going through. And we'll just tin our solder lead and Try to get these on here without destroying the board or pulling the wires back out. Okay. And there we go. Let me just go ahead and solder these up. Okay, so let's take a look at our solder job under the magnifying glass. I may need to trim these back, make sure they don't short out, because you definitely don't want to short these wires out. Let's see, we have 23, 3 volts, and the ground soldered in there. Okay. Now I may use, as I mentioned in some of my videos, sometimes I use dikes, but sometimes it's hard to get into tight places with dikes, but this is a fingernail clipper, and these seem to work pretty good for clipping down loose ends. You definitely don't want them to short out against something else though, because that would be a very bad thing. Okay, make sure all the extra wires are off the board. Okay, it's always good to check your circuit under the magnifying glass before you put the voltage on it. Once you put the voltage on it, there's no turning back. If you got something wrong, it's going to be ruined. Okay. And I think I may just connect the potentiometer up initially with clip leads before I solder it, or the flying leads before I solder it to the potentiometer, because I want to make it so that when I turn it one way, well, I guess it really doesn't make a difference. I can always correct for it in the software, but if I turn it one way, I want higher frequency, and turn it the other way, lower frequency, but I can always take the inverse of the number, I guess. Simple enough in the software. So, I don't know, either way. I think I'll probably just check it with the clip leads first and make sure I get the order right, though. Okay, so I hooked up our potentiometer with the clip leads, and I just loaded up this is an example. It's under, you go to Files, Examples, and Analog Input, and I loaded that one up. And this is just one of the examples that comes with the Arduino IDE, and I'm just going to modify this to test our Teensyduino here. And so I'm going to try to make sure that I'm getting an analog input that I can read, and I think it's probably on pin 9. That's my guess from, it's probably not, pin 33 is, or pin 23 is where it comes out, but it's labeled as A9, analog 9. And so I'm going to change LED pin to 9, what we'll guess there, and see if that works. And of course, we need to make sure that the Teensyduino board set on 4.0. Let's see, where is it? Which it is. This is 4.0. And we also need to make sure the serial port is connected. Okay. And okay. I'm trying to remember if it's supposed to show the board or not when it's on there. Okay, well, it seems to think that that's connected properly. Let me make sure I have some other things plugged in there. Unplug those. Okay, so I guess let's just, oh wait, you know what? I don't have the thing plugged in, that's why. Let me plug her in here. That's why we're not seeing it. Okay, so ID10T error, right? For all you computer nerds out there that know what that is. Port. Teensyduino. Okay, there it is. I thought it didn't look right. Okay, so let's try just uploading. We'll check the sketch to make sure it compiles properly. It looks like it is. It should. It's a standard example. We have everything configured properly. Let's pretty straightforward there. Compiling sketch. Oh, really? Okay. Okay, press the button to manually enter programming mode. Okay, for some reason they have a button here that you're supposed to press. And we'll try uploading our sketch. And it looks like it uploaded it properly. And it should be running right now. So the way you can access the what the Arduino thinks it's reading, if this is set up the way I think it should be, is you can go to Tools, Serial Monitor, and it should be giving back data, assuming this is set up properly. Okay, maybe they don't have it dumping to monitor. Okay, I'll have to see what I can do about that. Okay, I guess I downloaded the wrong program. I should have downloaded the first one, Analog In Out Serial. And it looks like this one has the serial print on it. And okay, it's already set up to analog input, analog out. Well, I don't want that one to be pin 9. What is AO? Let's just make this one like 5 or something, I don't know. And I'm going to change the A0 to pin 9, A9, because that's how it was labeled in there. We'll see if this works. We will check the sketch, and I'm going to kill this monitor while I'm at it. Okay, let's try uploading it. Okay, it thinks it's uploaded properly. Okay, so let's go into Tools and we'll do Serial Monitor. Okay, so it looks like it is outputting some kind of data. And let me try fiddling with our potentiometer here. And as I change the potentiometer, it's definitely changing the numbers. Going up higher, it goes up to 1,000. I go down lower, and it goes to 0. So I definitely think we can use this type of input to control the frequency of our Arduino here. Okay, things are looking pretty good. Okay. Okay, so see that? Twiddle the guy down, it goes down to 0, and twiddle it up, and it goes up to a very long delay. And I think that's the direction that I want it, because this is going to be higher frequency, so less delay. So I think I'll go ahead and solder this potentiometer up the way it's wired. Looks like I got it proper. And then we'll go on to the next step. Okay, should be interesting. Okay, so here we go. We got our solder on there, and our soldering iron. Come on. So I'll just go ahead and start soldering these guys up, and then we should be all set with the hardware side. Okay, so we have our Teensyduino, and I got this thing all soldered up here. And let's just twiddle with this, and we got our monitor up and running again. And it looks like it's still working. It's always a good engineering practice to test each of your steps to make sure you didn't mess something up. Make sure there's no wire shorting or anything. Look, everything's looking good though. Okay. There we go. See if we can get both of these in frame. Okay, so let's see. Here's my Teensyduino with the variable potentiometer on it. And wrote a little sketch. I started copying from I think it was the blinking LED example. I started with that. And LED So we have int LED, so this is the LED output that we're going to switch on and off very quickly. It's on pin number 13. And I'm just setting a bias, I'm going to call it num 400. That's kind of like a delay, or it's a delay that's going to bring the oscillation frequency into the range that we want it to. So you can set this a little bit higher or lower, and then we'll be able to add delay to that to shift the frequency down, basically. So this will be the upper limit of how fast this device can go. You could set this to like 0 or 1 or whatever, and then the analog output's going to have a let's see if we look here, 1223, and they were scaling it before, but I'm just keeping that value, whatever it is. That's the analog output from 0 to 1223. That will be how much extra delay we're going to add to this. Okay. CTL is going to be our counter that's going to put delay into our loop, and then B is going to be the value that we read from our potentiometer here. Okay. And then we have this constant int analog in pin A9, and I believe that this is some kind of special code that sets it to A9 no matter what Arduino pin it is, because remember we used that in this other sketch over here, and it worked for the proper pin A9, so I copied it over. And then in our void setup, we're going to set the LED output pin to output 13, right? LED is value 13. And then I'm going to start the loop, and I'm going to digitally write high, and then I'm going to put a little delay in here. And what I had to do for the delay, I wanted something that was took a very few number of clock cycles, so I could have finer increments in the delay, so you get more adjustability without so much granularity. And what I found that I had to do, I couldn't just put CTL equals CTL plus 1, because the algorithm, the algorithms that optimizes this sketch will basically breeze right through this. It'll say, oh, that's trivial, and you won't get any delay. It'll just take all those out. It says, I know what that is, I'll just add it up immediately. We don't even need to do a loop. So I found that if I put I in there, which is the for loop that it's counting on, it will not, the optimizer will not kick this out then. So this statement is complicated enough that the optimizer doesn't know how to automatically skip past it, and it actually does the for loop and does the proper delay. If we look at our for loop, we're going from num, which is our offset, plus b, which is whatever we're going to add the value from this guy, so we can increase the delay, and then of course plus plus increments the loop. Okay, and so I digitally write high, and then I digitally write low, and then I repeat this for a whole series of cycles. And it turns out that actually the analog read is very slow, and so here's our command for the analog read, and I'm setting that equal to B because I had to put that in there a lot of times. I didn't want to make a long variable name. But anyway, it'll have a whole pulse train, and then it will stop for a second and read, which is fine with me because I'm driving maybe Tesla coil or something. I don't mind if it has a little pause after the burst, as long as it has the proper frequency. And it would be difficult to try to put this in and have the micro PIC processor multitask and do the analog read and these other things very quickly. So I think this is going to be good enough for my purposes, and I may increase the pulse train longer. But this is basically our sketch, and let's test it out. Okay, so here is our Arduino, and we have our variable potentiometer here, and I can twiddle this back and forth, and let's get that in there. So I have this on pin number 13, I believe. Pin number 13 is the output, and so here's our variable potentiometer. And let me bring the camera over here so we can watch the scope as I twiddle it. See if I can juggle all this. Okay, so see, I can change the period, make it longer or higher frequency. And that's just by twiddling with this knob right here. See that? I'm twiddling with the knob and I'm changing the period. And let's just measure this, I guess. So this is the highest frequency that we're at right now. And we'll get that to about 1 period there. And so that's 347 kilohertz. And if I twiddle this guy down, okay, this will go to 103 kilohertz. Okay, so that's pretty good tunability. And anyway, this is a very interesting, fun project. And this is Dr. James, and thanks for watching.